misi yang satu, berbisik kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, selamat petang dan salam sejahtera kepada semua guru, ibu bapa dan semua pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi Youtuber dengan usaha Sama E-Didik Malaysia dan Kad Guru Malaysia. Bermula percuma, selamanya percuma. Cikgu perkenalkan diri dahulu. Saya Cikgu P, kini mengajar di Kolej Tingkatan 6 Tun Fatimah Melaka selaku moderator dan juga control host pada petang ini. Pada petang ini kita akan bersiaran langsung dari channel Cikgu Hasnitah. Siapa yang belum subscribe channel Cikgu Hasnitah, sila tekan butang subscribe sebagai tanda sokongan kepada Cikgu Hasnitah. So, Cikgu Hasnitah kini mengajar di SlinK Bagan Jaya, Pulau Pinang. Hari ini kita akan belajar subjek tingkatan 4 dengan tajuk 4.2 Specific Heat Capacity. Kelas ini akan bersiaran langsung lebih kurang 1 jam. Sebelum kita teruskan kelas, suka cikgu ingatkan kepada para pelajar dan penonton yang ingin menghantar komen. Sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian. Untuk tonton umum, cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar-pelajar yang cemerlang dan mari kita tunjukkan disiplin yang terbaik. So, link isi je akan diberi di hujung siaran nanti. Pastikan isi dalam tempoh 30 minit selepas kelas tamat. Link isi je boleh diisi dengan email e-didik dan MOE. So, sila fokus kepada isi pelajaran yang akan disampaikan oleh Cikgu Hasnitah. Semoga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh para pelajar. So, baiklah, saya serahkan kelas kepada Cikgu Hasnitah.
Okey, terima kasih Mr. P, sahabat saya dari Melaka. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat petang kepada semua yang sedang mengikuti kelas tuisyen online percuma kita di Akademi Youtuber dikuasakan oleh Kelab Guru Malaysia dan E-Didik Malaysia. Bermula percuma, selamanya percuma. Jadi sebelum kita mulakan kelas pada petang ini, jom yang beragama Islam, mari sama-sama kita mulakan dengan Al-Fatihah dan doa belajar. Bagi yang bukan Muslim, anda boleh bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Bismillah. Amin, amin ya rabbal alamin. Jadi insya-Allah mudah-mudahan kelas kita pada petang ini mendapat rahmat daripada Allah Subhanahu Wa Taala. Okey. Jadi tadi Mr. P dah perkenalkan, hari ini kita akan sambunglah kelas tuisyen online percuma bagi fizik tingkatan 4. Okey, tajuknya masih lagi bab 4 haba, iaitu tajuk yang kedua. Okey, 4.2 Specific Heat Capacity. Okey, so before that student, I would like to inform you the link for PDF copy for this slide is provided in the pin messages in the live chat. Seperti yang ditunjukkan pada skrin sekarang oleh Mr. P, anda boleh muat turun, boleh cetak keluar nota ini. Boleh digunakan sepanjang kelas ini berlangsung ataupun anda boleh tonton dulu kelas ini, nanti anda boleh isikan kemudian modul tersebut. Okey, mudah-mudahan membantu anda memahami tajuk ini dengan lebih baik. Okey, so without further ado, students, if you are ready, can you give me a sign? I'm ready, teacher. Sedia, cikgu. Siapa yang ada bersama kita pada petang ini, bolehlah say hi dekat live chat itu. Ada beberapa negeri yang umumkan cuti umum hari ni ya. Mr. P sempena PRN semalam, Kedah bercuti, Terengganu pun bercuti. Jadi bolehlah luangkan masa bersama-sama dengan kita pada petang ini. Kita ulang kaji sedikit. Okey, sebelum itu, untuk kelas fizik minggu ini telah disampaikan pada Jumaat lepas kelas tingkatan 5 oleh teacher SlindaNordin. Tajuk dia 4.1. Daya ke atas konduktor pembawa arus dalam medan magnet. So siapa terlepas kelas ini, jangan risau. Anda boleh tonton semula siaran ulangannya di channel teacher Slinda. Pergi saja ke channel YouTube teacher Slinda. Boleh tonton ulangannya di sana. Dan petang ini cikgu akan teruskan. Saya Cikgu Hasnitah akan sambung tajuk yang cikgu bincang minggu lepas. Okey, hari ini kita nak bincang 4.2 4.2 specific heat capacity. Okay, this class is not only for DLP students but for non-DLP also can follow because our slide is provided in dual language. Kita punya slide dalam dua bahasa. Jadi tak ada masalah. Pelajar DLP ke, pelajar bukan DLP, dua-dua boleh ikuti kelas pada petang ini, insyaAllah. Okey. So ini adalah tim sukarelawan bagi panitia fizik di Akademi Youtuber. Guru-guru inilah yang telah banyak membantu cikgu menerbitkan video-video PDPC ataupun kelas-kelas tuisyen online percuma. Mudah-mudahan semua video yang diterbitkan ini membantu anda dalam subjek fizik untuk SPM. Okey, dan siapa yang belum muat turun Mr. P, kita punya apps di Google Play Store yang kita namakan sebagai Akademi Youtuber. Okey, dalam ni ada banyak video PDPC daripada prasekolah hinggalah ke pra-universiti yang anda boleh manfaatkan. Jadi kalau belum lagi boleh download sekarang apps ini di Google Play Store anda bagi pengguna Android. Okey. Okay, now let us begin our lesson for this afternoon. Okay, kita tak banyak masa tapi kita ada banyak slide nak bincang. Cikgu harap sempat kita habiskan dalam 1 jam. Okay, students, so this is our content standard 4.2, specific heat capacity. Altogether, there are 5 learning standards. So the first one is to explain heat capacity. Macam mana nak terangkan apa itu muatan haba. Okay. So this is our first activity. Okay, if you look at this diagram, okay, for activity 1, okay, if you can look at the picture there, what is the situation? Okay, in the morning, a pail of water was taken from the pool and placed next to the pool. Okay, kita ambil satu baldi air kolam dan kita letak baldi tersebut di tepi kolam. Okay, and at noon, we find out the temperature of both water are different. Bila tengah hari selepas beberapa jam, kita dapati suhu air dalam baldi tak sama dengan suhu air dalam kolam. Walaupun kedua-duanya adalah sumber air yang sama. Even though they are the same sources of water, but during afternoon, the temperature for both are different. Okay, so what is the reason for this situation? Apa sebab kenapa suhu tak sama pada waktu tengah hari? Early in the morning, the temperature is the same, okay, at the pail and in the pool. But later at noon, the temperature will be different. And can you guess which water has a higher temperature and which one has a lower temperature? Okay. So the reason for this situation is due to different heat capacity, okay, for the water in the pool and the water inside the pail. Mereka mempunyai muatan haba yang berbeza. Kenapa muatan haba dia berbeza? Nanti kita lihat. Alright. Okay, next students. Okay, so from here, we can find what is the meaning of heat capacity. Apa itu muatan haba? Okay. So heat capacity, if you refer to your textbook, it is defined as heat capacity is the quantity of heat required. Okay, the quantity of heat required or needed to raise the temperature of the object by 1 degree Celsius. Apa itu muatan haba? Ialah kuantiti haba yang diperlukan untuk menaikkan suhu objek sebanyak 1 darjah Celsius. Okay, so you must very clear with the definition. This is under construct of remembering, mengingat. Okay, dan ini adalah formula. This is the formula for heat capacity. C is heat capacity, equal to Q. Q is amount of heat, okay, amount of heat required, quantity haba, and divide delta theta. Delta theta is the changes in temperature. Okay, so the unit for heat capacity from this formula is joule per degree Celsius. Okay, amount of heat is measured in unit of joule. Temperature different is degree Celsius. So the unit for heat capacity is joule per degree Celsius. Alright. So I hope you are clear with the definition. Okay, next. How can we determine heat capacity for an object? Okay, so look at the first example here. Okay, we supply 2000 joule of heat, okay, to two object P and object Q. And we found that object P experienced a rise in temperature for 1 degree Celsius, while object Q experienced a rise in temperature by 2 degree Celsius. Okay, which means we supply the same amount of heat to both objects, but we can see the rise in temperature are different. Okay, so how to find the heat capacity in both objects? So we use the formula I showed you earlier in P. So this is how to find the heat capacity. Q divide delta theta. So Q, remember, amount of heat supply 2000. You can take from the question. So the temperature change or the rise in temperature is 1 degree Celsius. Okay, so this means object P has a heat capacity of 2000 joule per degree Celsius. Kita ada Cikgu Kok di sana. Hi Cikgu Kok. Thank you for joining us. Cikgu Kok dari Melaka. Okay, then how about object Q, students? So we do the same thing. So this is the formula to find heat capacity. Q is the amount of heat supply, 2000. For object Q, the rise in temperature is 2 degrees Celsius. So we just do the substitution. And you will find heat capacity for object Q is, yes, 1000 joule per degree Celsius. Okay, so what this 2000 joule per degree Celsius mean? It means object P required 2000 of joule to raise its temperature for 1 degree Celsius. Okay. Meanwhile, for object Q, it requires 1000 joule of energy to raise its temperature by 1 degree Celsius. Okay, next. Okay, the second question. Compare the heat capacity of P and Q. Okay, so this kind of question you may found in paper 2, question number 5 and question number 6 in section A, making comparison. Okay, so from the answer we determined earlier, it is clearly that, yes, heat capacity for P is greater than heat capacity of Q. Or you can write vice versa. Heat capacity of Q is smaller than heat capacity of P. Alright. Okay, second, compare the rise in temperature of P and Q. Remember just now, rise in temperature for P is 1 degree Celsius. And for Q is 2 degrees Celsius. So which one higher, which one lower? It is obviously that the rise in temperature for P is lower or less than, okay, and rise temperature of Q. Alright. Okay, so for this question, you can use the mathematical symbol for equal, greater than, or smaller than. Alright. Okay, not other than that. Tiga simbol ini kita terima untuk perbandingan. Simbol sama dengan lebih besar daripada ataupun lebih kurang, lebih kecil daripada. Okay, next. Okay, so the question D, state the relationship between heat capacity and object rise in temperature. Okay, I prepare a GIF for you there. You can see clearly. Okay, when we apply same amount of heat to two objects of different heat capacity, object with low heat capacity will experience high rise in temperature. Okay, while for object with high heat capacity will experience low rise in temperature. Okay, so this is the relationship. When heat capacity of the object increases, so the rise in temperature decreases. So it is inversely proportional. Okey, muatan haba objek bertambah, maka kenaikan suhu objek berkurang. Okay, so I hope you are clear with the first example, how to determine heat capacity of two different objects. Okay, student, next. Okay, now we have the second example. Okay, now we have two kettle. Okay, both filled with water. Same type of water. Kita isi kedua-dua ceret dengan air, but with different amount, different mass. Okay, so both kettle S and T are switched on to heat up the water until they are boiled. Kita masukkan air dalam ceret S 1 liter, 2 liter dalam ceret T dan kita hidupkan pemanas sehinggalah air mendidih. Okay, so the first question, which kettle takes longer time to boil? Who would like to respond? You can share your answer in the live chat. Ceret mana yang mengambil masa yang lebih panjang untuk mendidih? Is it kettle S or kettle T? So definitely, yes, it will be the kettle with more amount of water. So answer is kettle T. Okay, then next question. Which kettle has higher heat capacity? Okay, so which one? Is it kettle T or kettle S? Which one has a higher heat capacity? So it will be the kettle filled up with more amount of water. So the answer is kettle T. Okay, then the third one again, right relationship between heat capacity and mass of a substance. Okay, so here actually this question want to teach us what is the relationship between heat capacity and mass of a substance. So here you can see when the mass of the substance increases, where it is 2 liter, so the heat capacity increases. Okay, mean we require more heat to raise the temperature of the substance. So again, mass of substance increases, so heat capacity increases. Apabila jisim bahan bertambah, maka muatan haba bahan pun bertambah. Okay, jelas I hope you're clear with the first and second example. Okay, now student, the second activity, okay, let us try to investigate the daily situation around us which involve heat capacity. Okay, if you look at the first situation here, okay, when you are drinking a hot coffee, okay, explain why a cup of hot coffee can cause more injury on a body than a drop of hot coffee. Bila minum kopi tiba-tiba tumpah, panas dan in the next situation, okay, we have a drop of coffee, okay, spill into your hand or your palm. So mana yang lebih teruk? Which one will cause us more injuries on your body? A cup of hot coffee or a drop of hot coffee? So which means here we want to compare the mass, okay, and relationship to the heat capacity of the coffee. So the answer is yes. A cup of hot coffee has a higher heat capacity compared to a drop of hot coffee. So it will cause us more injuries on the body. Okay, if the coffee is spilled on our body. Apabila secawan kopi panas tu dia tumpah, dia mempunyai muatan haba yang lebih tinggi. Maka dia akan menyebabkan kecederaan yang lebih besar ataupun lebih serius. Kenapa? Sebab jisim dia besar, so muatan haba dia besar. Okay, the mass is greater, so do the heat capacity is greater, bigger or higher. Okay, next. Okay, now students, let's take a look at the next situation. Why the metal parts or the dashboard of a car, dashboard itu is the front part of a car inside, get hot faster compared to the fabric cushion. Mengapa pemegang logam pintu itulah ataupun papan pemuka pada kereta terasa cepat panas berbanding dengan cushion fabric kereta? Okay, why? Okay, so this question asks you to explain, give your explanation or justify. So What happened here? Again, we compare the heat capacity of the two different material. So the metal part or dashboard of a car has a lower heat capacity, okay, compared to the fabric cushion. Okay, metal part of a car has a lower heat capacity compared to the fabric cushion. So remember, okay, an object or material with a lower heat capacity, the rise in temperature is higher. Okay, so the rise in temperature for the dashboard is higher compared to the fabric cushion. So that's why when we feel or when we touch, it will feel hotter. The dashboard will feel hotter compared to the cushion. Okay, the reason because it has lower heat capacity, so the rise in temperature will be higher. Maksudnya dia serat haba sikit saja, suhu dia meningkat dengan cepat. Okay, absorb a little amount of heat, the temperature will rise higher. Okay. Okay, then the third situation. Okay, this one involving a bowl of soup. Okay, so after being left to cool for some time, you will find the soup in a large bowl is hotter compared to the same soup which is placed in a small bowl. It is the same soup, but we put them into two different container. One in a large bowl, second in a small bowl. Okay, so how do we compare? So what happened to the soup in a large bowl? It has a higher heat capacity. Okay, and now we have same material. Both are soup. Okay, so soup in a large bowl has a higher heat capacity due to higher mass. Okay, so what happened? Remember, an object with higher heat capacity, the rise in temperature will be lower. Same goes to the drop in temperature will be lower. Okay, so this is the explanation. Thus, a temperature drop or decreases slowly. So it will be hotter compared to the soup which is poured into a small bowl. Okay, this one, soup inside a small bowl has a lower heat capacity. So the drop in temperature will be higher. Okay, so it cooled down faster compared to the soup in a large bowl. Okay, remember, heat capacity is inversely proportional to rise or drop in temperature. Okay, boleh faham Okay, now Mr. Pei, let us look at the take a look at the fourth situation. Okay, this we saw this every day. Sometimes when we feel bila malas nak masak kan ataupun tak sempat nak masak kan Mr. P, sometimes we just call delivery pizza. Cikgu Hasnitah pun biasalah, ada hari-hari yang sibuk kan, tak sempat masak, kita call sajalah Food Panda or Grab Food and anything. Okay, now titik pizza sampai dekat rumah. Okay, but this is apple pie. Okay, so the question is, okay, why the jam of a hot apple pie burns but the crust can be eaten instantly. Biasa kan kalau pizza baru sampai, kita makan yang tengah tu dia panas kan Mr. P, susah nak makan. But yang tepi-tepi tu dia lebih senang nak makan sebab dia cepat sejuk. Okay. So that's why setengah orang dia makan tepi dulu habis sebab dia sejuk. Yang tengah tu lambat sikit sebab dia panas. Okay, so why there is a difference between the piling, the jam and the crust at the edge. Kenapa ada perbezaan suhu? So what happened here, students, the heat capacity of the pie crust, okay, is smaller, okay, compare to the apple jam. Okay, heat capacity of the pie crust smaller compared to the apple jam. So the pie crust cool down faster compared to the apple jam, which is still hot. Okay, this one. So again, the difference in heat capacity of the pie apple jam and the pie crust. Okay, because the heat spread. Okay. Hantar sijil tak nanti? So far kita tak terima update sijil daripada admin. Okay, kalau kita terima update nanti kita kongsikan sijil di hujung siaran. Tapi buat masa ni kita tak terima lagi sebarang update daripada admin So kita fokus pada kelas terlebih dahulu. Okay, boleh cuba jawab. Because the heat spread, jawapan tu boleh perbaiki lagi. Actually because of the difference in heat capacity. Remember, a substance or material with low or smaller heat capacity will have a bigger rise or biggest drop in temperature, so it get cool faster. Okay, itu jawapan dan sebab dia. Okay, next. Okay, done with the first part, Mr. P. So we have done with the heat capacity, students. Okay, so again, what is heat capacity? It is the amount of heat required to change the temperature of an object by 1 degree Celsius. Jumlah haba yang diperlukan untuk menaikkan suhu bahan sebanyak 1 darjah Celsius. Okay, so that is the definition. Okay, now let us check for our second learning standard, students. Okay, define specific heat capacity. Okay, so this is the second term. The first term is heat capacity. Second, specific heat capacity of a material. Okay. Okay, so this is again the situation. Okay, heat. Okay, the sun heats up the sand and the sea water at the same period. Pada masa yang sama, cahaya matahari memanaskan pantai dan air laut. Pasir di pantai dan air laut. If I'm not mistaken, this is one question in SPM 2022. Ini adalah salah satu soalan dalam kertas SPM 2020. Kalau cikgu tak silap lah, okay. Nanti anda lihat tak lama lagi keluar dia punya koleksi jawapan sebenar. Okay, students. However, the sand gets hot quickly and the sea water get hot slowly. Okay, dia nak bagi tahu walaupun kita bekalkan haba yang sama daripada matahari pada air laut dan pasir, tapi pasir tu dia lagi panas dengan cepat berbanding dengan air laut. Okay, so kenapa ada perbezaan? Why there is the difference between the temperature of the sand and the sea water, even though we supply same amount of heat to both from the sun. Okay, that is your situation. So how to respond to this question? Macam mana kita nak jawab? Okay, so first, the concept here is referred to specific heat capacity. Okay, konsep dia muatan haba. Tentu boleh juga konsep muatan haba. Okay, heat capacity also can apply here. Okay, then what happened? Heat energy supply to the sand and sea water are equal. Okay, first anda boleh bagi tahu tenaga haba yang dibekalkan kepada pasir dan air laut adalah sama, iaitu tenaga haba daripada matahari. Okay, next. You can mention about the specific heat capacity for both. Okay, for sand. Sand has low specific heat capacity. So it absorbs heat quickly. So it has high rise in temperature. Yang ini kita belajar tadi in the first part. Pasir mempunyai muatan haba tentu yang lebih rendah. Okay, maka dia serap haba dengan cepat. So kenaikan suhu. While what happened for seawater has a high specific heat capacity. Okay, so it absorbs heat slowly and causes low rise in temperature. Air laut dia mempunyai muatan haba tentu yang lebih tinggi. Maka dia serap haba dengan perlahan. So kenaikan suhu dia adalah rendah. So that's why the sand has a higher temperature, higher rise in temperature compared to the sea water. So you can write the point separately. Dalam exam kita asingkanlah seperti ini. Kita tulis setiap point itu secara berasingan. So easy for the marker to mark, to see your point. Nak beri markah pun senang. Okay. Okay, next students. Okay, now let us do more research and study on specific heat capacity of material. Okay, now you are given case 2. Okay, we have two different material there, water and oil. Okay, water and cooking oil with the same mass, heated with the same amount of heat. Okay, but later towards the end, you will find out temperature of the cooking oil rises faster compared to the temperature of water. Kita ada minyak dan air sama banyak masukkan dalam periuk dan kita supply haba yang sama, tapi akhirnya minyak tu dia panas lebih cepat. Okay, kenaikan suhu pada minyak adalah lebih cepat berbanding air. Dia slowly. Okay, kenapa? Okay, what causes the difference? Okay, so the reason here is, yes, so water and cooking oil have different specific heat capacity. Air dan minyak ni dia mempunyai muatan haba tentu yang berbeza. Okay, itu jawapan dia. Okay then, okay, before we go to the definition, let us take a look at the next example. Okay, now we have two cubic. Cubic A, it is 1 kg of aluminium block. Okay, and we have cubic C, okay, 1 kilogram of lead block plumbum. Okay, so the question is which cubic needs large amount of heat to raise temperature by 1 degree Celsius. Okay, here you can see rise of temperature by 1 degree Celsius. Okay, to make this happen, it requires 900 joule of heat. Okay, for cubic C, to raise the temperature by 1 degree Celsius, it requires 130 joule of heat to do so. Okay, so the question again, which cubic needs large amount of heat? So you may highlight the needs of the question. Needs large amount of heat to raise the temperature by 1 degree Celsius. Obviously, you can see this one 900, this one 130. So which one need greater? Need large amount definitely will be cubic A. Kubus A memerlukan jumlah kuantiti haba yang lebih banyak untuk menaikkan suhu dia sebanyak 1 darjah Celsius. Dia perlu 900 joule heat. Yang C tu dia perlu 130 joule saja. Okay. So from here we can understand that 1 kilogram of lead, lead ini plumbum lah in bahasa Melayu, require 130 joule of heat. Meanwhile, 1 kilogram of aluminium require 900 joule of heat to raise the temperature by 1 degree Celsius respectively. Okay. So from here, can you, so we understand that different quantity of heat is needed to raise the temperature by 1 degree Celsius for cubic A and cubic C, even though their masses are equal. Walaupun berat dia sama, jisim dia sama, tapi sebab dia adalah bahan yang berbeza. So maknanya muatan haba dia adalah berbeza. Okay, so second, we understand different substance has a different specific heat capacity. Bahan yang berlainan mempunyai muatan haba tentu yang berlainan. Okay. Okay, now students, okay, from the example, now we can come to the definition for specific heat capacity, muatan haba tentu. Okay, so what is specific heat capacity? According to your textbook, it is defined as the quantity of heat required or needed to raise the temperature of 1 kilogram mass of substance by 1 degree Celsius. Apa itu muatan haba tentu? Ia adalah kuantiti haba yang diperlukan untuk menaikkan suhu sebanyak 1 darjah Celsius bagi 1 kilogram bahan. So, ada 3 keyword dekat sana. There are 3 keyword there. The first one, quantity of heat. Okay, the first keyword. Second, quantity of heat. Second, raise temperature. Then 1 kilogram mass by 1 degree Celsius. Itu adalah kata kunci dia. Kuantiti haba, naikkan suhu 1 darjah Celsius, 1 kilogram bahan. So there are 4 keyword there. You cannot miss. Okay, whenever you write the definition. So apa beza tadi muatan haba dengan muatan haba tentu? Muatan haba tentu ni kita specify untuk 1 kg. Okay, for specific heat capacity, it is specified for 1 kilogram substance. Okay, so boleh bezalah muatan haba dan muatan haba tentu. Heat capacity and specific heat capacity. Okay, and this is the formula for specific heat capacity. C is specific heat capacity. Simbol dia sama dengan heat capacity. Okay, but the unit is different. Okay, so Q is amount of heat supply, M is the mass of substance, and delta theta is the change in temperature. Okay, so when we rearrange, it become Q equal MC delta theta. Q ini amount of heat supply, M is the mass of the substance, C is the specific heat capacity, delta theta is the changes in temperature. Okay, so now let us test your understanding, but before that, Mr. P, how about the short break? Apa kata kita berehat seketika sebelum
boleh.
kita tengok contoh untuk muatan haba tentu.
Okay, so jangan ke mana-mana, kembali selepas ini.
Kita rehat sebentar. Tapi boleh dengar saya? Ya. Saya dengar. Tapi boleh dengar saya? Ya.
Ya. Okay, so baiklah, jom kita teruskan bersama Cikgu Hasnitah. Silakan Cikgu. Cikgu Hasnitah.
Okay, so kita teruskan Okay, terima kasih Mr. P. Okay, student yang baru masuk, terima kasih kerana bersama-sama dengan kita pada petang ini. We are now having an online free tuition with Akademi Youtuber, Physics Form 4, the content standard 4.2, specific heat capacity. Okay, we are now in our second learning standard 4.2. To discuss what is specific heat capacity. Okay, now let us take a look at this example, how to determine specific heat capacity for a substance. Okay, cuba anda tengok satu contoh di sini. Okay, the first question. Okay, what is the meaning of specific heat capacity of aluminium is 900 joule per kilogram per degree Celsius. Apa maksud muatan haba tentu aluminium ialah 900 joule per kilogram per darjah Celsius. Okey, soalan ni biasa kalau tanya akan soalan yang pertama kalau dalam soalan struktur ataupun soalan esei. Okey, so how to respond? What is 900 joule per kilogram per degree Celsius refers to? So it means that 1 kilogram of aluminium requires 900 joule of heat to raise its temperature by 1 degree Celsius. 1 kilogram logam aluminium perlukan 900 joule haba untuk meningkatkan suhunya sebanyak 1 darjah Celsius. Okay, same question with number 2. Now, what is the meaning of the specific heat capacity of water? 4,200 joule per kilogram per degree Celsius. Muatan haba tentu air 4,200 joule per kilogram per darjah Celsius. Apa maksud dia? Sama juga, tapi anda boleh tuliskan dalam struktur ayat yang lain seperti ini. Okay, boleh juga seperti ini. 4,200 joule of heat required to raise the temperature of 1 kilogram water by 1 degree Celsius. 4,200 joule haba diperlukan untuk meningkatkan suhu 1 kilogram air sebanyak 1 darjah Celsius. So mana-mana satu pun boleh tulis. Some student prefer the first method of writing. Another student prefer the second method of writing. Tapi kedua-duanya pun betul. Okay, tak ada masalah. Ini dia mention jisim dulu. Ada jisim, ada haba, ada perubahan suhu. Ini pun sama. Okay, it mention the amount first, amount of heat first, and then 1 kilogram water 1 degree Celsius. So ada 3 keyword dekat sana. The first one, you mention the amount of heat, 4,200. This one, 900. Okay. Second, you mention 1 kilogram mass. So 1 kilogram water. Here, 1 kilogram aluminium. And third, you mention about the temperature. Raise temperature by 1 degree Celsius. Okay. Raise temperature by 1 degree Celsius. Okay. So this is what is meant by the specific heat capacity for the material given. Okay, jelas Okay, next student, second question. Okay, now we have to do some calculation. So you may get ready with your calculator as well. Okay, we have metal Q. It has a mass of 2 kg. So you may highlight mass is 2 kg. Calculate the amount of heat that must be transferred to the metal to raise the temperature from 30 degrees Celsius to 70 degrees Celsius. Okay, given the specific heat capacity for Q for metal W is 500 joule per kilogram per degree Celsius. Okay, so this question asks you to find how much heat must be supplied, which means we are looking for Q. Okay, so this is all the given information. Mass 2 kg, this is the change in temperature. Final 70, initial 30, so the change in temperature is 40 degrees Celsius. So this is the specific heat capacity for metal W. So what is the formula required? Q equal MC delta theta. So we are looking for this Q. How much heat must be transferred? Mean how much heat must be supplied to metal Q. So you do the substitution. Mass is 2 kg. This is the specific heat capacity. And this is the change in temperature, 40. So you just press your calculator. So the amount of heat required will be 40,000 joule. Okay, the unit is joule, 40,000. Okay. And for question 3, how many joules of energy are required to raise the temperature of 1 gram or 100 gram of gold from 20 degrees Celsius to 100 degrees Celsius, given the specific heat capacity for gold is 129 joule per kilogram per degree Celsius. Okay, so we are looking for the same thing. How much joule of energy, mean how much heat required. Okay, so this is all the given information, but you have to be careful here since the mass is given in gram. So you have to convert into kg. SI unit for mass. So 0.1 kg. Okay, so this is the change in temperature. 100 is final, 20 is initial. So the change in temperature is 80 degrees Celsius. So this is the specific heat capacity. So we apply the same formula. Q equal MC delta theta. Alright. Substitution mass 0.1 kg, 129 is the specific heat capacity, 80 is the change in temperature. So it will give you, yes, 1032 joule of heat. Okay, so this is a very simple and direct question on how to apply this formula to find the amount of heat required in both questions. Okay, jelas anak-anak pelajar? Okay, kita tengok pula yang ketiga, the third learning standard. Okay, this one involve 2 experiment to determine specific heat capacity of water and specific heat capacity of aluminium. So, cikgu akan pergi touch and go saja sebab eksperimen ini saya percaya nanti anda akan jalankan bersama dengan guru anda di sekolah. Okay. So, I just give you the guide how to run this experiment. So, this is all the apparatus and material needed. Okay, so you can read from the PDF slide copy I prepare for you. So this is the procedure. Ni procedure dia, and this is the arrangement of apparatus. Okay, if you can see the apparatus there. Okay, this is the arrangement of apparatus. Power supply, immersion heater. Okay, this apparatus is for water to determine specific capacity for water. Thermometer there, beaker. So we wrap the beaker with tissue paper or any cloth. Okay, okay. Then students. Okay, so this is the procedure in English. Okay, from number 1 to number 7. Begin with the wrap the beaker with tissue paper and end up with, after 5 minutes, switch off the immersion heater. Record the highest thermometer reading as the final water temperature. Okay, next. Okay, so this is, let's say this is an example of information gained from this experiment. The power of the immersion heater is 36 watt. Okay, the heating time is 5 minutes. So in second is 300 seconds. The mass of the water is 0.42 kg. Initial temperature 27 degree. Final temperature after 5 minutes is 33 degrees Celsius. Okay, so how to do the data analysis? So remember, our aim is to find or to determine the specific heat capacity of water. Okay, so this is the formula. C, specific heat capacity of water. This is PT. What is PT? Amount of heat supply by the electric appliances. Okay, so this is mass of water and delta theta. Okay, first, how to find the specific heat capacity. So first we must know what is the heat supply by the immersion heater. Berapa haba yang dibekalkan oleh pemanas rendam. So this is the formula. Amount of heat supply by any electrical appliances is equal to PT. P is power, T is time of operation. So the power is here from the table, 36 watt. Okay, and the operational time is in second, 300. So the power, the heat supply by the heater is 10,800 joule. Okay, mean 10,800 joule coming from the heater, so will supply to the water. So how much heat absorbed by the water is Q equal MC theta. Okay, so the relationship, the amount of heat supplied by the heater is equal to the amount of heat absorbed by the water. Okay, we assume that no heat loss to the surrounding. So 10,800 supply by the heater. So same amount of heat absorbed by the water, 10,800 joule. Okay, so now we can determine the specific heat capacity. Okay. Okay, this one PT, amount of heat supply by heater. MC theta, amount of heat absorbed by water. So we put 10,800. M, this is the mass of the water. C, we are looking. Okay, we are looking for C, specific heat capacity for water. And this is the temperature change. Final is 33, initial 27. So if you calculate, you will find the specific heat capacity of water from this experiment is 4,285 joule per kilogram per degree Celsius. A bit higher than the actual value, 4,200 joule per kilogram per degree Celsius. Okay. Same goes for aluminium block later on. Okay, but here there are a few discussion we may consider yang boleh kita fikir-fikirkan. First, why does the beaker need to be wrapped with the tissue paper? Tadi you nampak gambar kan? Kenapa kita perlu balut beaker dengan kertas tisu ataupun kain? Okay, because we don't want to loss any heat to the surrounding. So to reduce heat loss to the surrounding, untuk mengurangkan haba yang hilang ke persekitaran. Okay. Second, why the final temperature theta2 not taken as soon as 5 minute heating time end? Kenapa kita lepas 5 minit kita tak terus ambil? Kita tunggu seketika. We wait for a while, then only we took the final reading. This is to make sure thermal equilibrium, okay, between the water and heater is achieved. Kita nak pastikan keseimbangan terma tercapai di antara air dan pemanas, barulah kita dapat suhu yang tepat, okay, as the final temperature. Okay, next. Is the value of specific heat capacity C gain from this activity greater or smaller than the actual value? Adakah nilai yang kita dapat daripada aktiviti lebih besar atau lebih kecil? Okay, kalau anda tengok tadi kita dapat 4,285, 4,285, but the actual value is 4,200. Mean the value we get is greater, bigger than the standard value. So why? This is because heat loss to the surrounding, okay, while conducting the experiment. Ada haba yang hilang ke persekitaran. So 4,285 tu dia termasuklah haba yang hilang ke persekitaran. Okay. Wan Ming, YouTube live saja cikgu. Apa maksud tu Wan Ming? Maksudnya apa? Nanti boleh tengok semula Wan Ming kalau tak sempat tengok daripada mula. Okay, itu ke yang kamu tanya? YouTube live saja ke? Nanti boleh tengok semula pada link yang sama. Okay, you can watch repeatedly. Okay. Okay, now second experiment. Now to determine specific heat capacity of aluminium. Okay, so this is the apparatus and material, bahan dan radas yang kita perlukan. Lebih kurang sama. Okay, cuma sini tadi sebika air kita gantikan dengan bongkah. Replace with a block of aluminium. Okay. Okay, then student, this is the procedure. Anda boleh bacalah daripada nombor 1 hingga nombor 4 langkah-langkah dia. Okay. Okay, then this is the information we gain from this second experiment. Okay, the power of the heater 50 watt. Heating time 5 minutes, 300 seconds. The mass of aluminium we are using in this experiment is 1 kg. This is the initial temperature before the experiment started, 27 degrees Celsius. And this is the final temperature of the aluminium block after 5 minutes heat up, 42 degrees Celsius. Okay, so we do as we do to the water earlier. So first, we find the amount of heat supply by the immersion heater. Remember, this is the formula. Q is the heat supply by heater, equal to power multiply time of operation. So the power of the heater is 50. Time of operation 300 seconds. So the heater supply 15,000 joule of heat. Okay, which means the aluminium absorb 15,000 joule of heat from the immersion heater. Okay, again we assume no heat loss to the surrounding. Okay, so now we can find the specific heat capacity of the aluminium by using this formula. Okay, PT again amount of heat supply by heater equal to amount of heat absorbed by aluminium block, MC delta theta. Okay, so PT 15,000. M, mass of block. You can find all the information from this table. C, we are looking for, okay, specific heat capacity of the aluminium. This is the change in temperature. Final 42, initial 27. So you will find 1,000 joule per kilogram per degree Celsius. Okay, this is the value we gain from this experiment. But actually, the actual value for specific heat capacity for aluminium is about 900 joule. Okay, 900 joule per kilogram per degree Celsius. Okay. So this is the few question. Okay, we can discuss. The first one, what can be done to obtain a better thermal contact between the bulb of the thermometer and the aluminium block? Apa yang boleh kita lakukan untuk pastikan sentuhan terma yang lebih baik, okay, antara berbuli termometer dengan blok aluminium? So if you notice, students, if you notice at the diagram of apparatus, ikut balik sekejap lah. Okay. Okay, this one. Okay. If you look carefully, okay, there is a hole here for us to put the thermometer in. Ada satu lubang sana tempat kita letak thermometer. So to make sure a better thermal contact, so we can add oil into the hole. Kita masukkan minyak ke dalam lubang itu. So it will causes a better thermal contact between the thermometer and the aluminium block. Okay, so itu jawapan dia. Adding all into the whole of aluminium block before inserting the thermometer. Okay, and second, given the standard value for specific heat of aluminium is 900 joule per kilogram per degree Celsius. So you have to compare the value and the value obtained from this experiment. So just now we obtained 1000, which is higher. Same goes to the water. This is due to heat loss to the surrounding when conducting the experiment. So selalunya nilai yang kita dapat daripada eksperimen akan lebih besar daripada bacaan yang sebenar kerana adanya haba yang hilang ke persekitaran. Okay. And these are the safety precaution you may write for both experiment. The first one, since we are taking reading from the thermometer, so you have to ensure your eye position must be perpendicular to the scale of the thermometer. Pastikan kedudukan mata berserenjang dengan skala thermometer. Okay. Yang kedua, kita mesti letakkan beaker di atas kepingan polystyrene. Okay. Put the beaker on the polystyrene sheet for both. Okay, this is actually to prevent heat loss to the surrounding. Kita tak nak haba tu dia mengalir melalui meja yang kamu letakkan tu. So kita letak penebat insulator below the beaker or below the aluminium block. Alright. Okay. Satu lagi boleh tutup lah. Okay. Switch off the power supply when not taking any reading. Kita tutuplah bekalan kuasa apabila tidak mengambil bacaan. Okay. Okay, that is the 3 safety precaution you may write. Okay, Mr. P. Okay, now let us take a look student at the 4th learning standard. Okay, kita tengok yang keempat. Is to communicate to explain the application of specific capacity in our daily life. Kita nak tengok apa contoh aplikasi muatan haba tertentu dalam hidupan seharian kita. Ada beberapa contoh dekat sini, semua ada dalam buku teks actually. You can find that. The first one, okay, selection on building material of traditional houses in various climate zone. If you notice, most of the traditional houses are made from wood. Dibuat daripada kayu. Kenapa pilih kayu? Sebab apa? Kayu dia ada muatan haba tentu yang tinggi. Wood has a high specific heat capacity, so it get hot slowly. The temperature rise slowly. So this is to make sure the temperature in the house is cooler, always cool. Okay. Especially in a warm weather region. Traditional houses built from wood function as an insulator of heat from the scorching sun. Kita pilih rumah daripada kayu sebab dia berfungsi sebagai penebat haba. Okay. Manakala di kawasan beriklim sejuk juga dia perbuat daripada kayu sebab dia pun penebat haba yang baik. So dia elak haba daripada keluar. So it keep the houses to be warm. Sebab dalam tu mereka pasang unggun api, right? So in a cold water region, traditional houses also built from wood, which function as a good heat insulator. So heat from the fire lit in the wooden house cannot flow out. Okay, so it keep the heat inside the house. Okay. Okay, then students. Second, cooking utensil, peralatan memasak. Okay, if you look for the cooking utensil, the body normally made from metal work. Dia punya badan tu dibuat daripada logam, bahan logam. Kenapa? Because it has low specific heat capacity. So the rise in temperature will be higher. So the food can be cooked in a short time. Badan dia kita buat daripada besi selalunya. Kenapa? Sebab besi tu dia ada muatan haba tentu yang rendah. So kenaikan suhu dia cepat, maka makanan tu boleh dimasak dalam tempoh yang singkat. Okey. Manakala ada juga periuk yang kita buat daripada clay pot, tanah liat. Ini fungsi dia untuk apa? So, clay has a high specific heat capacity. For this kind of pot, it help the food to stay hot for a long period. Kalau kita nak makanan tu dia kekal panas, kita letak dia dalam periuk tanah liat. Sebab apa? Muatan haba tentu dia tinggi. So dia punya penurunan suhu tu lambat. Okay, suhu dia turun dengan lambat, maka makanan tu dia kekal panas dalam tempoh yang panjang. Okay. Itu beza dia. Okay, then back to cooking utensil. Okay, normally for a metal pot, the body is made from metal or aluminium. Kenapa? Sebab dia ada muatan haba tentu yang rendah, low specific heat capacity, so it heat up quickly. Okay, while for the handle normally made from wooden or from any material with high specific heat capacity. So the handle of the pot get hot slowly. So suhu dia meningkat dengan perlahan. Pemegang dia, kita tak nak dia panas. Alright? Okay, senang saja. Okay, third, cooling system of a car engine. Sistem penyejukan enjin kereta. Okay, normally the coolant is water. Kita guna air lah sebagai penyejuk. Kerana apa? Air ni dia ada the first one, it has a high boiling point. So not change to vapor easily. Air dia punya takat didih yang tinggi, 100 darjah Celsius, dan dia tidak mudah meruap menjadi wap. Kedua, air ni dia ada muatan haba tentu yang tinggi, 4,200 joule per kilogram per darjah Celsius. So dia penyerap haba, dia akan serap haba dengan banyak. It has a high specific capacity, so absorb a lot of heat from the hot engine. And third advantages, it is abundant, economical. Dekat Malaysia ni mana-mana boleh jumpa air. Okay, and it is also cheaper and save cost. Mudah didapati, murah dan kos dia pun rendah. And this is the cooling mechanism, student. Ini adalah mekanisme penyejukan. Okay, yang ni kadang-kadang dia tanya ni dalam exam 4 markah. Explain the cooling mechanism in a car engine. Okay, so what happened here first? The water is pumped into the engine block. You can see the pump there. Water is pumped into the engine block. Okay, then the water flows through the engine block and absorb the heat produced. Okay, and this hot water flows to the radiator. You boleh tengok radiator sana. And then the cool air is sucked in by fans. Ada kipas ni, fungsi dia untuk tarik udara sejuk dari luar. Okay, and at the same time, heat from the hot water released through cooling fin. Dalam masa yang sama, udara panas yang di dalam enjin tu dikeluarkan melalui sirip penyejuk. Okay, this one. So you can read later on the 4 step of cooling mechanism. Okay, in the car engine. Okay, fourth, outer layer of a space capsule. Lapisan luar kapsul angkasa. Okay, so this is this issue. Okay, when a space capsule is in its journey back to Earth, they will encounter air resistance when entering the atmosphere. So this will causes the friction, will causes the rise in temperature, and it can burn the space capsule. Boleh terbakar. So kita nak elak dia daripada terbakar apabila dia kembali semula ke bumi. So how to solve that? Macam mana nak selesaikan? So this is the modification we've done to the outer layer of the space capsule. Okay, the first one, it is made from a high specific heat capacity material. The reason, so the temperature rise slowly. Okay, second, we can make the outer layer from a material which has a high melting point. Buat daripada bahan yang mempunyai takat lebur yang tinggi. Sebab apa? What is the reason? So it will not burn easily at high temperature. Tidak mudah terbakar atau tidak mudah melebur pada suhu yang tinggi. Okay. And next, production of latest material in construction of the green building. Bangunan hijau maknanya yang environmental friendly, yang mesra alam, reduce the carbon footprint. Okay. So normally the roof material is made from insulating concrete roof. Kita buat bumbung daripada konkrit yang bertebat. Okay. Example, can use styrofoam board because it has high specific heat capacity. The reason is to reduce absorption of heat from the surrounding and at the same time reduce temperature inside the building. Okay, kita nak kurangkan haba diserap daripada persekitaran, dalam masa yang sama nak kurangkan suhu dalam bangunan. Okay. Okay, yang keenam, yang ini natural phenomenon. Fenomena semula jadi. Bayu laut, sea breeze, students. Okay. So what happened at the daytime? If you are standing on the shore during daytime, you can feel the air is blown from the sea towards you. Anda boleh rasa ada angin yang bertiup dari arah laut ke arah anda. Okay, so this is what we call as a sea breeze. What happened? Land has a lower specific heat capacity compared to the sea. Darat dia mempunyai muatan hambatan tu yang lebih rendah berbanding dengan air laut. So what happened? The temperature of the land rises quickly. Remember, the lower the specific heat capacity, the higher the rise in temperature. So hot air on the land rises upward and create lower pressure region. Udara panas di darat naik ke atas, dia akan hasilkan kawasan tekanan rendah. So what happened? Cold air from the sea will move towards the land as sea breeze. Udara sejuk dari laut bergerak ke darat sebagai bayu laut. Senang saja cerita dia. Okay. And then what happened at night, berlaku pula sebaliknya. Pada waktu malam, kalau anda berdiri di tepi pantai, nanti anda akan rasa angin tu datang dari belakang. Ada angin datang dari belakang yang bertiup ke arah laut. Okay, opposite to what happened during daytime. Okay, so why? Kenapa macam tu pula? Okay, yang ini samalah. Sea has a higher specific heat capacity compared to land. Okay. This will causes the temperature of the sea drop slowly, okay, compared to the temperature of land. So laut ni dia suhu dia lambat nak turun sebab dia punya muatan hambatan tu besar. Okay, darat tu dia lebih cepat penurunan suhu dia sebab muatan hambatan tu dia kecil. Okay, then hot air above the sea rises upward. Okay, create low pressure region. So finally, the cold air from the land move towards the sea as land breeze. Maka udara sejuk dari darat bertiup ke arah laut sebagai bayu darat. Senang saja cerita dia. Okay. And students, okay, I think we have come to our last learning standard, final learning standard 4.5, 4.2.5 to solve problem involving specific heat capacity using this formula. Okay, Q equal MC delta theta. Okay, we have 3 or 4 questions there. But before that, let us take a look at the conversion of energy involving heat. Ini adalah perubahan tenaga yang berlaku yang melibatkan haba. Okay, the first one, electrical energy convert into heat energy. When you are using immersion heater, macam dalam eksperimen tadi. Okay, so electrical energy supplied by the heater equal to the heat energy absorbed by the substance. So this one, PT. Electrical energy equal to heat energy absorbed. Okay. Second, when an object drop from certain height. Okay. Apabila kita jatuhkan sesuatu objek dari satu ketinggian, so the changes of energy is from potential energy to heat energy. Heat energy itu due to friction or air resistance when it drop. Okay. And third, kinetic energy. Any moving object. Okay. Kinetic energy convert into heat energy, again due to friction. Okay, so and this is the formula, mgh potential energy equal to mc delta theta heat energy. And for kinetic, half mv squared, this is kinetic energy equal to the heat energy gain. Alright, okay, now okay, first example. We have a kettle with a power 1000 watt. Find the amount of heat generated in 5 minutes. Okay, so how to do this? Very easy. Q equal PT. You are given with power there 1000 and the time is 5 minutes. Just convert into second. So this is the amount of heat generated, 300,000 joule. Okay. Okay, second, B. The rise in temperature of 750 grams of water in electric kettle is switched on for 5 minutes. This is the specific heat capacity of water. Okay, find the rise in temperature. Okay, you are given mass of water, operation time 5 minutes, and specific heat capacity. So, which formula? What energy changes to what energy here? So, Q equal MC theta. Okay, so we want to find the rise in temperature, mean delta theta. Okay, so this one 300,000. Sama tadilah. Okay, ini soalan yang sama lah. Okay, continuous from A. Okay, so this is the amount of heat supplied just now by the heater, 300,000. So mass of water 0.75 kg. Okay, this one convert into kg. This is the specific heat capacity. So the temperature change is 95.238 degree Celsius. Okay, ada Celsius di sana cikgu tertinggal. Sorry degree Celsius. Okay, you add Celsius back there, degree Celsius. Okay, next. Okay, question 3. Okay, now we have 200 gram of water with a temperature of 40 degrees Celsius mixed with 800 gram of boiling water. So we have two water at different temperature. Okay, if there is no heat loss to the surroundings, so what is the final temperature of the mixture when they achieve thermal equilibrium? Okay, so this is the situation. So how to solve for this question? Okay, macam mana nak selesaikan? Okay, so this is the conversion of it. Heat absorbed by the water with lower temperature equal to the heat release of the water at higher temperature. Ini the changes of heat occur between both water. So we label M1 C1 delta theta 1. Ni M2 C delta theta 2. Okay, so we do the substitution. This is for the water with the lower temperature. Okay, lower temperature, the mass 0.2 kg C, and this is the final temperature T. Okay, minus. Why minus? Because final temperature will be higher. Okay, for the water at 40 degree. Okay, this one for the other side, this is the second water, 800 grams, so 0.8 kg. So this is the final temperature. So the final temperature will be dropped. Okay, so that's why we minus 100 minus T. Okay, so we solve. So finally we'll find this is the final temperature of the mixture, 88 degrees Celsius. If you notice, student, the final temperature, 88 degrees Celsius, must be in between 40 degree and 100 degree. Okay, between the initial temperature of both water, 40 degree and 100 degree boiling water. Okay, so the final temperature is 88 degree Celsius. Okay, and another question here, we have a lead bullet moving at this velocity, heat ascend back. Okay, temperature rise about 50 degrees Celsius. Assuming all kinetic energy convert into heat energy, so find the specific heat capacity of the bullet. So here, the changes of energy is kinetic energy into heat energy. Okay, so heat generated by the bullet equal to the kinetic energy loss by the bullet. Okay, so this is the formula. So we are looking for specific heat capacity of the bullet. Okay, the mass is not given, so you just cancel M at both sides. Okay, so finally we'll find the specific heat capacity of the bullet is 400 joule per kilogram per degree Celsius. Okay, okay, I think this is the last question for today. Okay, now we have a lead ball with this mass, 320 grams, is dropped from a height. So drop from a height, so we know the changes of energy is potential energy, gravitational potential energy convert to heat energy. Then assuming all energy goes into heating it, find the change in temperature. Okay, so we want to find delta theta. So this is the conversion of energy. Potential energy loss during the fall equal to heat energy gain by the ball. Okay, so this is the formula. mgh, potential energy, mc delta theta for heat energy. Okay, so you just do the substitution. This is the mass in kg, 320 gram, convert into kg. 9.81, this is the gravitational acceleration. Okay, and 12, this is the height. It's written there, 12 meter. Okay, this is the mass. So we are looking for delta theta, temperature change. Okay, So you will find the temperature change is 0.9197 degrees Celsius. 0.9197 degrees Celsius. Okay. So I guess that's all for today. So I have shared to you 5 learning standard on 4.2 specific heat capacity. So if you miss any part of this session, don't worry, you can come back later and you can rewatch repeatedly until you get the full content of this lesson. Okay, Alhamdulillah itu saja masa yang kita ada. Sebenarnya agak terlajak lah daripada masa yang biasa. Okay. Sebelum tu cikgu dah dapat update daripada admin. So sambil cikgu share, saya serahkan kembali dulu kepada moderator untuk pesanan yang seterusnya. Silakan Mr. P. Sebentar saya sharekan link sijil Mr. P. Tapi boleh dengar saya? Sekejap cikgu sharekan link sijil sebentar . Okey. Okey, pelajar dapat dekat sana ada link sijil. Cikgu sudah kongsikan. So pastikan anda isikan dalam tempoh 30 minit lah selepas kelas kita ini bersiaran. Okay, masukkan nama, maklumat email guna email e-didik ataupun email MOE lah atau email delima. Okey. Okey, Mr. P boleh dengar saya ke? Boleh.
Okay, so terima kasih kepada Cikgu Hasnitah. Selesailah kelas kita pada petang ini. Okay, so tahniah dan terima kasih kepada semua yang mengikuti kelas daripada awal hinggalah sekarang. Okay, so sekiranya anda miss out, okay, handout daripada Cikgu Hasnitah yang sangat berguna ini, so boleh gunalah link yang saya paparkan sekarang. Okay, so sebelum kita tamatkan sesi siaran langsung ini, mohon tutup rangan, cek, klik butang subscribe dan aktifkan loceng supaya anda tidak terlepas sesi kelas Cikgu Hasnitah seterusnya. So sila klik like dan share link kelas kita pada hari ini kepada rakan-rakan di media sosial. Mudah-mudahan pelajar beroleh kebaikan di atas perkongsian tersebut. Okay. Okay, so jangan lupa ikuti kelas fizik yang seterusnya di mana pada setiap hari Jumaat 9.30 malam kita ada kelas tingkatan 4. Dan next week kita akan masuk 4.2 arahan ke Melektan dan akan disampaikan oleh Cikgu Izyan kan. Okay.
Yes, betul.
Dan seterusnya untuk kelas hari Ahad seperti hari ini pukul 3.30 akan disampaikan oleh saya, okay, Mr. P. So kita akan sambunglah subtopik yang ketiga 4.3 specific latent heat. Okay, so kita haraplah semua boleh sharekan kelas kita sebab kelas kita sebenarnya percuma untuk kebaikan semua pelajar dan juga guru-guru. Okay, so link sijil seperti tadi Cikgu Hasnitah sudah sharekan. Okay, seperti ini. Okay, so kamu perlulah ambil perhatian, link ini akan tamat dalam tempoh 30 minit. Okay, pastikan anda login dengan email e-didik dan MOE. Okay, so sebelum kelas tamatkan, Cikgu Hasnitah ada apa tambahan untuk semua?
Sedikit saja pada saya. Alhamdulillah, syukur kita berjaya habiskan kelas pada petang ini. Okey, jangan lupa boleh muat turun boleh download, cetak keluar nota yang cikgu lampirkan. Anda boleh dapat pada pin message ataupun pada deskripsi video. Pergi ke deskripsi video, ada link dekat sana, boleh muat turun. So, join us again next week with Mr. P 4.3 latent, specific latent heat, and for Form 5 student with Cikgu Izyan, Jumaat 9.30 malam, kelas tingkatan 5, tingkatan 4, Ahad 3.30 petang. So terima kasih kerana sentiasa menyokong kami di Akademi Youtuber. Mudah-mudahan semua dapat manfaat dan kebaikan daripada apa yang kita kongsikan pada setiap minggu, insyaAllah. Okay, Mr. P, terima kasih.
Okay, so terima kasihlah seperti Cikgu Hasnitah katakan. So kepada semua penyokong Akademi Youtuber, doakan kita terus kuat dan bersemangat untuk membantu dalam membangunkan pendidikan di Malaysia. Sekian daripada kami. Okay, jumpa lagi minggu depan. Okay, bye-bye.
Hai. Selamat.